short demo of where you might going to create a new pluggable database in a RAC environment where there already exists a standby, but you do not need the pluggable database to be protected by the standby. This could be a situation where you need the PDB just for a couple of days. You could be using this PDB for some simulations or for some tests, or you could be testing some interfaces with the new PDB. So you don't need it to be protected for more than at all, because you don't need a standby. You might create a new PDB in the existing environment because you do not have another development environment to create the new PDB. It might take too long to set up a development environment, a test environment. It might take too long to make the firewall rule changes for your application interfaces to connect to the test environment to do this testing. So as a quick method, you create a new pluggable database from your existing production database, don't protect it with the standby, and then discard it 2 days later. So first let me just connect to my existing production database. If you use an account that is privileged to query PDBs, maybe a DBA account, but not necessarily, it could be select catalog role or select any dictionary. You can get the PDB name from the $PDB's view. So this is the PDB that I'm connected to, or in SQL Plus, if you're using SQL Plus, you can do a show con name to show which PDB you've connected to. Now this is a good practice Oracle has been recommending since multi-tenant was implemented. Oracle has been recommending for RAC and DataGuard, do not use the standard default name of a PDB as your service name. When you create a PDB, there is always a default name as a service name, but always use custom names, and there are very good reasons for it. You could look up the multi-tenant and the RAC documentation. So for those very good reasons, although I have a pluggable database called PDB1, I am using a service name called my PDB. So for this demonstration, I'll just create a table which will simulate transactions. Timestamp. So the application that will be doing this testing is more interested in the transaction details and probably the transaction timestamp. But for this demo, I'm also capturing which PDB I'm connected to. Okay, so when I create my new PDB, I can show you that it's a different PDB from this existing pluggable database. And also because it's RAC, I just want to capture which host name I've connected to, because if I've connected via scan, I don't know which of the 2 instances or the 3 instances in my cluster that I was connected to. Oops, sorry. Just gonna recreate this. Then I'm going to just insert my first transaction. Again, because I'm using an account that has the privilege to query PDBs and instance, I can get the pluggable database name and the host name from those 2 views. Let me just save this query. just select back from the table, because I'm going to use this table to demonstrate what happens when I have a new PDB. Sorry. Okay, so I have inserted as of now, this is UTC, remember this is in the UTC time zone. As of now, I've inserted some dummy data into a pluggable database called PDB1, and my connection, although I was connected from SRV1, because I connected via a service name myPDB in a rack environment, I got actually connected to the instance running on SRV2, which is fine. I'm okay. It's rack, so I can connect to any instance, but I'm more interested in knowing that I'm connected to the right PDB. So here this is my test table. Now I'm going to create a new pluggable database as a clone of this pluggable database. So I connect back to the root. Okay, before that I'll just show you that DataGuard is currently working. So as soon as I issue an archive log current from one instance, the other instance also does an archive log switch. Show you that again. So you can see here there's another archive log switch that happened, right? And the standby is receiving and applying. It's doing real-time apply of the archive logs. So this is fine. Now I'm going to create my new pluggable database, but I will specify that my new PDB as a clone of PDB1 will not have a standby copy. So this is, although it's in production, it's for a testing for a few days, so it is fine. PRDAPPTST will be my PDB name. I'm creating it as a clone from PDB1. So when I created the clone from PDB1, all the local users in the pluggable database, all the local table in the pluggable database, all the table spaces will also be copied. There are ways to do a no data copy clone. If you look up my blog, I have blogged about that also, how you can create a clone without data. But here I'm going to create a clone with data, with all the users, table spaces and tables. But now the catch is, there is an additional clause in the recent version of Oracle where when you specify standbys, you can specify the names of the standbys. If you have multiple standby databases for your primary, you can specify which standby database you want it to be created on. If you specify standbys is equal to all, then the standby copy is created on all the standby environments. And if you specify standbys is equal to none, it gets created on no standby. It is still in the primary. So in this case, my primary is a rack cluster, so it's accessible from both nodes of the cluster, but there will be no data files created on the standby. The control file will be updated. The data dictionary information for the pluggable database will be updated in the $CDB root. So the standby will receive that information in the control file in the root, but not the data files. So the standby will not consume disk space for the data files for this new pluggable database. So let's watch what happens here at the standby. So now you can see the standby says okay, a new pluggable database has been created, so it has been registered in the standby, but it says all the data files are skipped because this is a refresh clone, not this rewrite mode, but because this is a refresh clone. So it's created as a no standby pluggable database. Okay, in this case it's offline, it's just created as a no standby database. So there are various reasons why you would have a standby but no data files being created. So some of the reasons are obvious from this explanation. So now I have my pluggable database in the primary. Let me do a few log switches also and show you that. So I'm doing log switch from the primary, and you can see that standby is still receiving and applying redo, although some data files are missing, right? So, and when I issue a archive log current from the primary instance, the second instance in the primary will also do an archive log. Let me just put some data into my pluggable database right now without using service name. So I just my new pluggable database is called PRDAPPTST. Oh, wait a minute, I have not yet opened it, so I'm opening the new pluggable database PRDAPPT in read-write mode on all instances. So here you can see the second instance in my rack cluster. It's opened my PRDAPPTST. Are there any violations? If there are any violations, let's see. PRDAPPTST, what it's saying is, because I created it without specifying a different service name, it gives me a warning. Okay, it inherited the same service name as my PDB1, and now it's conflicting. So this is a very dangerous situation. If you create a clone without specifying a service name for the clone, you can have a conflict, and any application that connects to this service name might connect to either of the two PDBs. In another video, I'm going to create a separate video to demonstrate how to handle that service name issue. For the time being, let's see if we can connect to this pluggable database. PRDAPPTST. Okay, I had a query called INS query, right? Okay, so I can still access this because I'm not using a service name. I am explicitly specifying my container here. I'm not connecting via service name. I explicitly connected via a container, so I can query this. I can query this pluggable database. I can query this table, and I can update the table. If I were to just query again from the table, so my second entry is actually in all because I connected locally from srv1 in SQL Plus with set container. I am still on srv1, but I am now in the new pluggable database. So this is one way you can do it. But of course, now my problem is this warning about the service name. Service name is in conflict. So I'm going to create another video where I will demonstrate how to handle the service names. But I'll show you the service name configuration. So currently the service called myPDB is configured, okay, to connect to either instance, okay, and it will connect to PDB1. So there's only one service name which is configured to connect to PDB1, but the new pluggable database, when I opened it, it raised a warning message saying the service name has been inherited with the same name. So you might have issues connecting. So it's always preferable to create a new service name. So let's do that. Let's create a new service name for this as well. So what service name should I give? I should not use the default name, that is the pluggable database name. Okay, my pluggable database name is PRDAPPTST, so I should use a different service name. So this is the service name I'm going to use, and the rest of the parameters I'm going to specify the same as they are for the existing service my PDB, which connects to PDB1. Okay, so I can specify it across multiple lines. Remember, this is the container database name RACDB. These are the instance names. Okay, this is the service name, and then towards the end I will specify which pluggable database is. So don't confuse yourself. Container database is one, instance name is one, service name is one, and PDB name is one. They're all four different logical names. In fact, container database is physical and pluggable database is also physical. Since this is a rack environment, there are parameters like transparent application failover policy, failover type, and connection load balancing goal. So this I'm not going to go into details of how failover and connection load balancing are done in rack, but essentially this means select transactions can fail over. If I'm connected, for example, to the instance name running on SRV1, and my connection and the SRV1 goes down, my connection will automatically fail over to SRV2. That is RACDB2 on SRV2. That's my failover definition. Connection load balancing is on the server side, where I've defined a service. When a request comes in, the server side can also specify load balancing based on short transactions as the goal. And the PDB name I'm going to connect to is PRDAPPTST. So this is how I create a new service for this container database. These two instances, this new service name mapped to this new pluggable database. So let's look at the configuration again. So if I just run srvctl config for service, then it gives me all the services that are configured. So since this looks like too many lines, I'm going to say okay, I just want for the new service name. So here it is, newtestpdb. These are all the failover and load balancing goals, and it's specified for this pluggable database, and connections may go to either of the two instances in my rack cluster. Do I need to enable it once I created it? Let me just verify. Okay, so it's already enabled. When you create it, it's enabled. Why would you have a disable status? Is when you want to disable it for some time for maintenance. You want to disable service to make it non-accessible, and then you re-enable it later after your maintenance is over. So it's already enabled. So it's enabled but not running, so I'm going to start the service. Oops, what was the syntax error? Service start service. Okay, so the service is started. And now it's running in both instances. Now this is service has been started on the server side, but what about the clients or the application servers? They need to have a TNS name or a JDBC connect string, right? So if it's JDBC connect string, they can write the JDBC connect string, they can construct it. But let's say I'm using a TNS Zora, so I'll just edit my TNS Zora. I'm not going to do this connection load balancing because that's not part of this demo, but I just take these lines. Now you see the beauty of this whole concept of services. You do not need to know the PDB name. The client that is connecting does not need to know the PDB name. If I use service names, service name myPDB connects to service name myPDB. I mean the label newtestpdb connects to service name, but I do not know which physical PDB I'm connecting to. The name of the physical PDB is managed by the cluster on the server side. Okay, so the client does not need to know which. If in the old days when you used SIDs instead of service names, SID would map to the database instance. But when you have service names, one database instance, even if it's not multi-tenant, can have multiple service names. One database with multiple pluggable database can have multiple service names. One database with multiple pluggable databases can have multiple service names for each PDB as well. If I want, I could create one more service name called newtest2 connecting to the same PDB, PRDAPPTST. So I could have two different sets of users connecting to the same new pluggable database, and I could for maintenance purpose I could shut down one service and let one set of users connect to the other service name. But for simplicity, I'm just showing you one service mapped to one pluggable database. So this service I show you, newtestpdb, is mapped to this pluggable database, PRDAPPTST. Since this pluggable database is created as a clone of the existing pluggable database, PDB1, everything, users, tables, data is copied across. Now I know if I've connected to newtestpdb, I can see I'm in the PRDAPPTST. So this is the row I inserted. Let me just do one more. What was that query name? I don't want to rewrite the insert statement. Now I don't need to qualify my table name with my schema name because I am connected as my own user. Oops. So I can just run this again. And if I query, now you notice that because I connected via a service name, this latest connection was via the service name, I got connected to srv2, although I am still running from srv1. So when I connect via service name, I connect to either node of the cluster, because this service is running on both instances of the cluster. Okay, so it doesn't, I don't need to know which service, which PDB I'm connected to when I use newtestpdb. I don't need to know which instance I'm connected to when I use the service name newtestpdb. So this is in the pluggable database called PRDAPPTST. Let me go back to the other one. Oops. So the service name I had configured for PDB1 is actually my PDB. So if I query there, I only see that first one row that I created. So I've cloned my PDB1 to PRDAPPTST. The first row I inserted in PRDAPPTST was using a local session with alter session set container. The second row I connected using a service connection, that is using the service name called newtestpdb. Okay, so I'll put in all these commands later in the comments to my YouTube post. So one more thing, if you scroll back here, you will notice that the new pluggable database will be created without data files, but redo apply is still running. So how can I still verify? Okay, the alert log says redo apply is still running. How can I verify that? I know I cannot query this pluggable database because it's been created without any data files. Okay, right? But what about the existing PDB1? So let's just insert some more rows. Let's just insert a few more rows. So in PDB1 I have 3 rows which were created, and in this PDB, but the other rows are in the other PDB. So let me just verify whether those rows got propagated to the standby. So now I'm in my standby database. I'm going to connect to my PDB1. Voila. So these additional rows that I inserted at 3:30 did come across to the standby in PDB1. Of course, I will not be able to query the other PDB because there are no data files for the other PDB. But that means even if you create a pluggable database with standby is equal to none, the other PDBs will continue replicating transactions to the standby. If you know, in the earlier releases, when you were not able to do this, is if you have a database and you have a standby database and one data file does not get created in the standby database because you don't have standby file management auto, for example, or you run out of disk space in the standby database, then redo shipping will continue, but redo apply would have halted. If data files are missing in the standby, redo apply would have halted. But in this case, this standby has data files missing only for PRDAPTST test, but not for PDB1. So redo shipping and redo apply will continue working. So this is a good way where you can create a new pluggable database called PRDAPPTST without data files in the standby, define a service for it as well, and then use it from your application side. So now your application, if they connect to a service called newtestpdb, they will be in PRDAPPTST, right? And if they connect to a service called myPDB, they'll be in the pluggable database called PDB1. I hope this is clear. I'll put in the commands in my comments to the YouTube post as well, or you can also scroll through back and forth through this video a number of times to understand the commands. Thank you.